Hello everyone, I welcome you all to my class. In today's class, we are going to see the continuation of the last class, that is about the irrational numbers. So let me just recap you about the last class. In last class, we studied about the irrational numbers, like what is their definition. We all know that any number of the form p by q, where q is not equal to 0 and p and q are integers such that they are co-prime to each other are rational numbers. But any number which cannot be expressed in this form is an irrational number. So the ones which are not rational, which are not of the form p by q, are called as irrational numbers. After that, we moved on to the irrational number theorem, which stated that if you have a prime p and if that prime p divides a number a square, then that prime p also divides the number a. And using this theorem, we solved problems wherein we used this theorem to show that a particular number is an irrational number. Now, in today's class, we are going to we are going to solve two more problems of showing that a particular number is an irrational number. So, the agenda for today is to solve two problems, and both the problems we are going to show that the given number is an irrational number. Now, I hope you all remember the technique of contradiction that I taught to you in the last class. A quick recap of that technique too. We all know that if at all the question comes to prove a given number as an irrational number, we are going to prove it by the contradiction technique. So the entire technique was divided into 4 steps, and you have to follow the 4 steps religiously in order to solve problems of this types. So in this technique, the first step that is there is to assume the opposite of what is asked. We have to assume the opposite of what is asked. Then, since we have assumed something, that is why we have to derive the consequences using various logical mathematical steps. And after that, after solving or after writing the logical steps that are followed by this assumption, we actually arrive to an absurd or incorrect fact or statement or conclusion. Then we can say, we have got something that is absurd, we have got something that is incorrect, so it's a contradiction. And hence we can conclude that whatever we had assumed was wrong and the original given fact is correct. So again, there are 4 steps. First is assuming the opposite. Second, using it to derive certain consequences. Third, the consequences will lead you to a contradiction. And fourth, you are going to use the contradiction and say that assumption was wrong and hence the given statement is correct. Now let's begin with solving the problems. The first question is, you have to show that 5 minus root 3 is irrational. As I have told you, we are going to use the contradiction technique in order to show that the given number is irrational. So, in step number 1, we are going to assume the opposite of what is given to us. So, step 1. Assuming the opposite. So, we are being asked to prove that the given number is irrational. We have to assume the opposite. And what is the opposite of irrational? It's rational. So, we assume that 5 minus root 3 is a rational number. So, assume that 5 minus root 3 is a rational number. Now, since we have assumed that 5 minus root 3 is a rational number, as per step number 2, we are going to derive the consequences of our assumption. So, step 2, deriving consequences. Always remember, students, consequences are of the actions that we take. or it corresponds to, or it's an outcome of something that we have done previously. So here what we have done previously, we have assumed that the given number is a rational number, and that is why now we are deriving the consequences of this assumption. So if we have assumed that this number is a rational number, then according to the definition of a rational number, the number 5 minus root 3 can be represented as P upon Q, where Q is not equal to 0 and P and Q are co-prime integers. Now let's continue. That is, we are going to actually use certain logics in mathematics, and we are going to see exactly where we are reaching to. So now what I'll do is, I would isolate this term, the root term that is there in this equation, and I would move all the other terms on the right hand side of the equation. So when I move 5 on the other side, in order to isolate root 3, I get minus root 3 equals to P upon Q minus 5. Now I just want root 3 on the left hand side, that is why I am going to multiply the equation by minus 1, or I am going to multiply both the sides of this equation by minus 1. So this implies, since minus into minus would be plus, so I would get root 3 on the LHS, and on this side I would be getting minus into P upon Q minus 5. Now when I put this minus sign inside the bracket, what I get is root 3 is equals to minus P by Q plus 5. So this implies root 3 is equals to 5 minus P by Q. I have just commuted the terms. I have just written 5 first and later on minus P by Q. So now students, I want you all to observe this term, and specifically I want you all to observe the right hand side of this equation. The right hand side of this equation is 5 minus P by Q. We all know that number 5 is an integer. We know that P and Q both are integers, so the resultant of this would be an integer. And if you subtract two integers, you would of course get an integer. So here on the right hand side, when you perform all the operations and whatever be the value of P and Q, considering that they are integers, what the resultant of this term, I'm talking about the term on the right hand side, it would always be an integer, or it would always be a rational number. So we would say that it would be a rational number, right? So now on the right hand side, we are getting a rational number. Now I want you all to observe the left hand side. Is root 3 a rational number? Of course not. It is not a rational number. It's an irrational number. So we are equating two different types of numbers to each other. It's like we are equating minus 1 with 1, or I can say I'm equating 4 oranges with 4 pens. Oranges and pens are completely two different entities. I cannot equate oranges with pens. I can say 4 pens is equal to 4 pens. But I cannot say 4 pens and 4 oranges are the same thing. So it's like that I cannot equate an irrational number with a rational number that I am getting on the right hand side of this equation. So when I assume something wrong, when I derive the consequences of that assumption, I reach to a contradiction. What is the contradiction? So this is our step number 3. Finding the contradiction. So this implies that root 3 is rational, but this is a contradiction. Now why is this a contradiction? Because root 3 is irrational. So with this, we come to step number 4, that is conclusion. So this implies that our assumption is wrong, and therefore 5 minus root 3 is an irrational number. So this is our conclusion, that is step number 4. Before revising this problem, I would just want to mention that in exam, while you are writing the solution for such problems, you are not supposed to write these headings like step 1, step 2, step 3 or step 4. That is, these headings are written by me to make you understand the flow of the problem, but you're not supposed to write this in exam. Okay, you can keep them in your mind, you can revise them again and again, and accordingly solve the problem. So use this as a trick to solve this problem. So to sum it up all, I have assumed the opposite, that this number is a rational number. I have derived the consequences. The final step of the consequences, this equation, that is root 3 equals to 5 minus p by q, where this is a rational number, this is an irrational number. That's a contradiction. So then I found out the contradiction, which is step number 3, and finally we concluded with step number 4 that our assumption was wrong, and hence the given number 5 minus root 3 is an irrational number. So I hope students you have understood this problem. The question is the same. We have to show that 2 root 3 plus root 5 is an irrational number. We will move a little faster in this problem, and also I won't be writing the steps over here. I would be just writing how your answer should look like. So let's start the solution of this answer, this question. The first thing is we are going to assume the opposite. That is, assume that 2 root 3 plus root 5 is rational. Now we are going to derive the consequences of this assumption. So this implies that 2 root 3 plus root 5 would be equal to p upon q, where q is not equal to 0 and p comma q are co-prime integers. Alright, now again, this is a short form that I have used, but it is advisable for you to not use such kinds of short forms in your paper. Now what we are going to do is, again our agenda would be to come to such type of equation, okay, wherein I would have one root term on one side of the equation and the other side of the equation would be something of this form. So let's see whether we are able to get it or not. So for that, first what I will be doing is I would be squaring both the sides of this equation. So squaring both sides, we get 2 root 3 plus root 5 the whole square equals to p upon q the whole square. Now students, this is of the form a plus b the whole square, and we all know the expansion for this algebraic identity. It is a square plus 2ab plus b square. According to the given problem, our a is nothing but 2 root 3 and our b is root 5. So now we are going to use this identity and we are going to expand or open this term. So we get 2 root 3 the whole square plus, that is a square, plus 2 into 2 root 3 into root 5 plus b square, that is root 5 the whole square. And on the other side I am going to open up the square, so I would write the numerator square upon the denominator square. Now here again I would be opening up the bracket. So 2 square is 4 and square root gets cancelled. So 4 into 3 plus. Now 2 into 2 is 4. We are going to multiply the two irrational numbers with each other. So root 3 into root 5 is root 15. Plus again square and square root gets cancelled. So we get 5. this is equal to p square upon q square. Now 4 into 3 is 12 plus 4 root 15 plus 5 equals to p square upon q square. Now 12 plus 5 in this case is 17. So we get 17 plus 4 root 15 equals to p square upon q square. Now here if you see students, we are getting something of this form only. So again, over here we isolated root 3 in the similar manner. Over here we are going to isolate root 15. So for this, what we are going to do, we are going to send all the other numbers on the other side. So we will get 4 root 15 equals to p square upon q square minus 17. So that is root 15. Now I would be sending 4 on the other side. 4 over here is multiplied with root 15. Where it goes on the other side, it would be divided by this entire term. So I will get p square upon q square minus 17 the whole divided by 4. Now this is the end of your step number 2 of deriving the consequences. Finally, we have got a great consequence. What it is? That if you observe the right hand side of this equation, we have p square, we have q square. Both of them are integers. It is going to result into a rational number, and this 17 is again an integer, 4 is an integer, so there is no possibility of these numbers being an irrational number. So whatever the values of p and q would be, we know one thing for sure, that the resultant won't be an irrational number, it would be a rational number only. But on the left hand side we do have root 15, and what do we know about root 15? It is an irrational number. So we have come to a contradiction. We actually found out the contradiction. And what is the contradiction over here? That you are equating an irrational number with a rational number. So this implies that root 15 is a rational number, but this is a absolutely right. This is a contradiction, because you have to always give the reason, because root 15 is irrational. Now if root 15 is irrational, then we can conclude that this implies our assumption obviously was wrong. And what was our assumption? That 2 root 3 plus root 5 is irrational. If it's wrong, then we can say therefore 2 root 3 plus root 5 is an irrational number. So to revise, we started with step number 1, that is assumption. So this is our step number 1. Then we derived the consequences. This is the end of the consequence. So this is step number 2, deriving the consequence. Then this is step number 3, where we found out the contradiction, that this number is not a rational number, it is an irrational number, and that is why we could conclude that 2 root 3 plus root 5 is an irrational number. So I hope students you have understood this problem also. With this we come to the end of today's class, and before ending this class I would once again want to revise what we have done in today's class. We started with, first of all, going through what we did in the last class. I did revise the contradiction technique that is to be used in order to prove these two sums, and hence our agenda for today, that is completing these two problems, is done. Okay, if you have any doubts, you can post them in the comment section and reach out to me. Thank you so much for staying with me. Thank you.